All right, so 7-6 example side generally has some pretty good questions on it. So let's try 32. That's one of the questions we generally have. All right, 32. Let me try to outdo my cough, man. All right. So first, we're going to write it as a single log. All right, so we want to combine these. We'd have the natural log of 2x times x. So it'll be like that, all equals 5. And then I'm going to end up multiplying that together here in a minute, but even if you didn't do that, you could bring this part over and write it exponentially. So x times 2x plus 1 equals e to the 5th. Okay, how many made it that far? All right, and we can bring that in, get 2x squared plus x equals e to the 5th. So what you got to train your mind is anytime you see e, it's not a variable, it's actually a number. E to the 5th is a number. Okay, so right now you have a quadratic on one side, and over here you have e to the 5th. You could do this two different ways. First, you could actually treat it like a quadratic. So I'm going to remember where we're at right here. Okay, we're going to come back to that here in a minute. But you could treat it like a quadratic and set it equal to 0. That means your c term is e to the 5th. And then use the quadratic formula on it. So opposite of b, or negative 1 plus or minus b squared, or 1 squared, 1 minus 4 times 2 times negative e to the 5th. All over 2, okay? 2 times 2. All right? And we kind of keep cruising through it. We got negative 1 plus minus square root of 1 minus, and we have 8 times negative, so this is actually a plus now because you have negative 4 negative e to the 5th, so 8e to the 5th all over 4. Now if I put that piece into my calculator, I come up with two different answers. I come up with 8.37ish and negative 8.87ish, rounded there. Okay, and when I look back to my, anytime I get a negative, I need to look back to my problem and see if I put that in for 32. Is there, right here, if I go 2 times negative 8, I get negative 16 plus 1, that's going to be negative, and here I automatically get negative. So you want to test it out, see if it's going to give you a negative. You can't have the log of a negative, so the negative portion of our answer is not acceptable. It's extraneous, no solution for that part. We get this as our solution. Okay? The other piece you could do, if we go back to right here, you could grab your graphing calculator. So if you have a graphing calculator, follow along. If you don't, look at your neighbor who has one and follow along with them. Okay? You could take your graphing calculator, and in your y equals menu, you could actually put in two different equations here. Okay, we could call this portion, let me highlight it here. This portion right here, we could call y sub 1. Okay, and we could call this portion over here y sub 2. Alright, so we have y sub 2 is e to the 5th, y sub 1 is 2x squared plus x. So you have two equations. And really what you're doing is you're seeing where those two things will equal each other. So y sub 1, y sub 2, we've got e to the 5th. And we hit graph, we see absolutely, well, we see a parabola. I guess we see something. Where's e to the 5th?
It's like 1,000.
Far away.
It's far away. So let's go zoom, and let's go to zoom fit and see if it'll fit our graph there, if we'll see everything. Okay, so my parabola there. And all right. So there we've got it. Now, can our solution be a negative?
No.
No, in this problem it can't be, because if we take a look at it, we have that negative piece. So put it in there, but so we'll ignore this 0 over here where it intersects, but or not this 0, but this intersection. Over here, we'll try to calculate that. So what button do I use to calculate?
Second trace.
Good, second trace. We go to which one?
Intersect.
Not 0. Intersect. We want to see where they intersect. Okay, it's asking you, what do you want your first curve to be? Do you want it to be 2x squared plus x? And I'm like, yeah. And then second curve, do you want it to be that? Of course. And guess, well, I need to move my cursor closer to this point of intersection than to that one. So there we go, I'm closer to that one. My intersection is 8.37-ish. Hey, dude, that's what we have. Okay, so that's the other route to go. All right. Questions? Nick? 24, the big 2-4. All right. Okay, starting out on this problem, you got the 2, so let's go ahead and get rid of that. That's 2 times that log. So you think of these as 2 different pieces. All right, so we're going to move the 2 over first. And the way we do that is divide by 2. Okay, so we get the natural log of 3x minus 4 equals 7/2. Then we move the natural log over. Realistically, that's making that e to the 7/2 power. Then isolate x by adding 4. See, the opposite of subtracting 4 is to add 4. Notice I'm not calculating e to the 7/2. Okay, and then I'm dividing by 3. So e to the 7/2 plus 4 all divided by 3. Now when you're putting that into your calculator, be careful. If you're going to put that whole top piece into your calculator, the e to the 7/2, or yeah, e to the 7/2 plus 4, make sure that you don't put it in like this. Because right there you're saying e to the 7/2 plus 4/3. You're only dividing the 4 by 3, whereas you want to divide that whole numerator by 3. So, whoops, I forgot insert there. Let's try that again. Unbelievable. There we go. Delete, delete, delete. All right. Insert. There we go. Okay, so you'd want to put it in like that, so that you're dividing the whole thing by 3. 12.37, the other route a lot of students do is they just forget about this part up here to begin with. They just put that part in, and then they go divide by 3 on that. Okay? Good question. Other questions? No other questions, man. Yes? 30, the big 3-0. Okay, we're going to multiply them. Natural log of 4x equals 2. I'm going to bring the natural log over, which raises that. That's e to the 2nd equals 4x. Then divide by 4, e to the 2nd over 4. So x is approximately, I don't know, I have to look. 30, 1.85. Okay. Yes. 34. All right. 34. 34 is the other one that usually comes up. So 32 and 34 are kind of the tougher ones. If we did 33, that would usually come up as well. But I've already started this one other time. I'm putting parentheses around that. So this is our 2 natural logs. I'm going to combine those by using the quotient property. Okay. I'm now going to write it exponentially. So we bring that natural log piece over. It's e to the 11th. Okay. I am not, you just set whatever right over there. Thank you. Okay. And now I want to get rid of the fraction. How do I do that? multiplied by x. 3x minus 4 is equal to e to the 11th x. Remember, e to the 11th is a number. Okay? So now, if we knew this number, if we said this was like 1000x, what would our next step be?
Add 4.
Or let's just say it's 1x. What would we do? Okay, subtract 3x. Try to get your x's on the same side, right? Okay, so let's try to get our x's on the same side. So I got negative 4 equals e to the 11th minus, or e to the 11th x minus 3x. Okay? All right, now, what does this equal? Well, what is e to the 11th? It's like 50,000 something? 59,873? 4 point something, right?
0.1417.
All right, we'll just say blah, blah, blah there, right? And then x minus 3x. Okay? Well, is this going to give me a positive or negative over here? Well, it's a positive on this side. We now have 71 x's, essentially. Okay? Can x be negative here? Right, if we divide by this, we end up with, well, negative 4 and 59,871. We get a negative number. Whoops, sorry. You get a negative number. Okay, if we look back to the original problem and we put negative in here, is that okay? No, so this is a no solution. Good questions. Other questions? All right, turn your paper over, please. Your assignment today, it's 12 through 44. Now, two different things. First, I'm going to give you the option to do 7 through 11 for extra credit, and this is how quick they go. I'm done with 7. I'm done with 8. I am now done with 9. Done with 10. Done with 11. And I just did those in my head. And you guys should be able to do them in your head as well if you remember what we talked about yesterday. Those 5 are extra credit. Okay? 12 through 44. Show your work, ask questions, check your work. Okay? Now, I need you to also take out this page. We're going to change the due date on this to Tuesday. Total yeah.
Thanks, bro.
Tuesday the 3rd, that way you can do more fun log stuff this weekend instead of this. Most of you are already almost done with this. Let's turn the page over because I want to talk to you about this part of it. Shouldn't take a long time, however, first, make sure you answer this question. Okay? Second, when you are graphing y equals e to the x and you plug all these things in for x, you're going to get values. And in fact, if you put it into your graphing calculator, which a lot of you do, and you use the table, you'll get the values. Okay? When you put this into your graphing calculator, it's going to give you an error message on this one and this one. -2 and -1. If you write error there, then you get it wrong because it's not an error because the graph exists on those spots. Okay? And -2 and -1. So you can't put this into your graphing calculator and get these values because you'll be taking a log of a negative. Correct? Okay. However, if we're inputting, we're saying our log equals a negative. However, if we are inputting these into our y, then we should really isolate x. That makes sense? This is your input. This is going to be your output. Remember, it's an inverse, so we want to flip them around. So in this case, when I rewrite this in exponential form, tell your neighbor what you get. Okay, rewriting it exponentially moves this over here. That becomes e to the y equals x. That is what you're putting. That's where you're putting your negative values. That'll give you solutions there. Make sure that on this part down here you actually list examples for each using numbers. Okay, Nick?
How do we put the e to the y in our calculator?
You don't.
Oh,
You plug those in for y. Yeah. Good question. Yeah, you don't put this into your calculator, you substitute in. Okay?
Jolly bad.
Yeah, it won't be that. All right, have fun. Woo-hoo. Hey, can I have your attention back up here real quick? Problem that came up, this problem right here, or you'll get an answer that looks like this today, e to the 27th. It gives you 5.320482406 E11. Now that E does not stand for the natural number E. That means times 10 to the 11th. So that's 5.320482406 times 10 to the 11th. That's scientific notation. You could write it out like that. You could abbreviate it as 5.3 times 10 to the 11th. Or every time you multiply by a power of 10, what happens?
Goes up this.
Good. The decimal goes up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We add 2 zeros. So 53204824060, comma, comma, comma. Yes, 532 billion 48 240 600. Okay, that is the solution. There's no word "and" in there for all those that like writing "and." Hey, and I saw at Burger King they're still offering 5 for $1 Yumbos. Okay, 5 for, well, that's what it says. Yumbo, dude, 5 for $1. That's what it says on their sign up there. So walk in later and go, hey, could I get my 5 Yumbos for $1? And when they go, no, dude, that's not what it means. Okay, and they put the dollar sign out here, say, dude, your sign is stating the wrong thing. That's false advertisement, man. Okay?